everyone. Welcome to Wiki National Bioenzyme Council's first podcast series. Wishing all the women a very, very happy Women's Day. The theme for this International Women's Day is Inspire Inclusion, to understand and value women's inclusion so we can forge a better world, a better planet. And the tagline also, which says, invest in women to accelerate progress. This holds so true to our Wiki Bioenzyme Council as well as Bioenzymes Entrepreneur Academy, which believes in creating and promoting entrepreneurs who are passionate about fighting the climate crisis. Today, we'll be meeting one such wonder woman who has been working on water pollution, the Jalnayak herself, none other than Dr. Mrs. Snehal Donde. Dr. Mrs. Snehal Donde, with a plethora of almost 3 decades in the field of academics, has contributed a lot to various educational institutes in Mumbai and across the country. After earning 2 masters and 2 doctorates, she is currently pursuing PhD in philosophy of Hinduism and Ecology from University of Mumbai. She has played varied roles in educational arena like principal, lecturer, field coordinator of extension projects, visiting faculty, research guide, education consultant, and honorable director, and so on. Dr. Mrs. Snehal Donde is the chairman, SKECT Women Water Warriors, and recognized as the Jalnayak by the Government of Maharshtra, national convener for Aviral and Nirmal Ganga campaign in West Bengal and Tripura region, and member of the World Water Council. She's working for Ganga in West Bengal, Howrah-Gomati in Tripura, Bhatsa, if I'm not wrong, Kamvari and Arjunali in Bhiwandi, and Ulhas and Waldhuni in Ulhasnagar-Ambernath, Arjuna and Rajapur, river rejuvenation and propagating river basin management among locals. Aao Nadi Ko Jane or milkar bachaye Jal Jangal or Zameen. This is her motto. So we are so happy and proud to have you as one of our first guests for this podcast series. Very welcome, a very, very warm welcome to you, Dr. Snehal Donde.
Thank you so much for giving me this opportunity and looking forward to give my inputs as much as possible. Thank you so much.
So, ma'am, our first question to you would be, what factors or motivations led to you to pursue a career as a wastewater management professional?
See, first of all, I believe in it is ability to find your own voice and inspiring others to find others. Okay, that is what is Stephen Covey's best habits, it has been said. And I always believe that when you have to do something, you have to do in the area which is not much explored. And that was what I thought, that I have to go with the waste management. And also, when we look into being an educator and a researcher, when we look at our, content of the syllabus, what we teach and what we, try to do research, the things which are there in the books and what we see in the reality is totally different. And that's what is the gap, which I always thought that we have to, we have to bridge that gap. And then also, mostly we do the studies, which we do for the publication research and all. We don't do an application based. That is what very much necessary, that today we have to be the solutionaries. And being a very prominent member, all those which you said in my introduction, being in the Indian River Basin Council and the World Water Council member and all that, I got to see so many rivers and so many places, including where I'm staying, like in Mumbai region and the Thane region. Everywhere when I look around, all the rivers are almost completely of the garbage or the drainage discharge. So from that point of view, I always thought that I have to do something in the field of waste management. And that's how, when I got an opportunity in the Fulbright grant, Fulbright SIR, Scholar in Residence program, when I was invited as an expert, I chose to work on the sewage treatment plant because I wanted to do a global review of wastewater. So that's how I thought of progressing and making actually myself, unless I become completely equipped, I will not be able to propagate the things rightly. So that's how I always believe that unless I conceive I should believe in that completely, and then only I can achieve something. So that's how I figured it, that I would like to work in the field of waste management, and I started the journey. So still walking on it.
That's really amazing, ma'am. And we need more and more women to come forward. Like I mentioned in the beginning, also, the progress always begins with the women working in that field. So definitely we see a lot of progress.
Sure.
So coming to the toxic chemical parts, how do the chemicals added during the wastewater treatment process contribute to the harm in water bodies and the surrounding environment? And not just the water body, but even the surrounding environment is,
Absolutely.
tend to become a problem.
Yeah. So tell you very frankly about the global review when we were taking about the sewage treatment plants. Just to give an example of the case study of Manhattan, when I saw that wastewater treatment plant, which is 285 million gallon capacity. Why I'm talking about this 285 million gallon capacity rather than talking about our sewage treatment plants, because mostly when we are producing, if we are producing 100 mld, we have almost everywhere half the capacity or very low capacity STPs. We don't have such big ones. Recently, they have started coming in, like in Delhi, one has come, and now in Pune and other places, it is being talked about, because now we feel that we should also have as much capacity we are producing the sewage, that much capacity plants we should have. But to tell you very frankly, after conducting the study in Manhattan and looking from the perspective of, looking from the efficacy of the principles and the science of sewage, when we try to look at the infrastructure which has been created, it is almost 100 years old kind of a setup or establishment, which we are still going on with the same kind of a architectural engineering design, even with the technology. Now, looking, if we talk about this conventional, that's why we call it as a conventional STPs, because they are designed as such. You know why? And to tell you the reasons why we call it as a conventional one, because if we look at the main part of this STP are the activated sludge process, that is the secondary tank, secondary unit. But there, many places very uniformly they go ahead with the membranes, which are called as the bacterial membranes, which they put SBR, MBR, and all those things. But these membranes which they put in the activated sludge process, the bacteria which they say that they are cultivating there, when they put this kind of bacteria and they call it as a bioreactor, and they are pumping a lot of atmospheric air, whereas bacteria doesn't require atmospheric air at all, because with the oxidation reduction reaction, whatever the oxygen is produced, with that organic matter degrades. So there is no question of atmospheric air blowing which is happening. 75% of the energy is wasted in that, which is actually not required. To give you very precise answer to that is, that when we make curd, we have to take just a small pinch and we put it in the milk and keep it overnight. We don't agitate even. It gets completely curd formation. So you can imagine that how bacteria has worked completely and that curd formation is there. So, but then in these kind of processes, lot of atmospheric blow which is being done, air is being blown, then the dilution with which it is brought, like suppose now per capita, per person's amount of water which is given is 250 in America. Here it is 120. But if we are multiplying 120 into number of population in our place, and that much of water completely we are bringing into the sewage treatment plants, that means we are bringing all the diluted things. Because this STP is for the purpose that we have to degrade our organic matter, that the poop is supposed to be brought in, not the domestic water, other water and other things. They can be treated separately, but we bring it here. Then again, not only this, that there is, see, microbes always work very well in the condition where they have a natural condition like soil. The soil microbes and the sewage microbes, that means water microbes, in the symphony, they work very well. That means the metabolic pathway which happens, it's only the degradation happens with this kind of a molecular breakdown of the symphony between the soil bacteria and the sewage bacteria. So that's how it happens. It doesn't need cannot happen in isolation in those kind of a tank. And in the process, in the sewage treatment plant, there is a lot of sludge which is getting produced then. The reason behind it is when we bring so much of diluted water, we are bringing more of eukaryotes rather than prokaryotes in the system. And when there is lot of eukaryotes, means the chitin and the cell walls and all those things, they don't degrade by these microbes, the eukaryotes. So what is happening? A lot of sludge is being produced. Now, what America and others, they are doing, instead of doing with the wastewater treatment, treating the waste, they have converted into water resource recovery facility. That means they are trying to recover biogas, they are trying to recover electricity. That's how they are going ahead with. But the degradation of organic matter is not happening, and that's how NASA has also said that the oceans have become the global toilets. Because if you the last process, that means the tertiary tank, when it reaches in the STPs, they are trying to treat it, this tertiary treatment with sodium hypochlorite. Now just imagine, can this sodium hypochlorite kill the pathogens? It's not. And that's a wrong notion, that we are disinfecting with that and then we are releasing water. Literally, I could show them how nitrification is happening in the tertiary tank. Literally, I could show them that all the things are not in in this kind of a system, like conventional system, which still we run with. We are only wasting a lot of energy, money, but ultimately the output is we are carrying the pathogens to the landfills by the means of sludge, and the water which is discharged after the treatment is also having the pathogens. And that's the reason that today we are not able to use our water bodies for swimming, kayaking, or catching fish or anything. And fishes also, when we see the number have degraded, the quality has degraded, everything is degraded, the spawning number is degraded. So all these things gives an indication that our treatment process is not proper. So that's how I think that, and in the process, it's spread in such a big area. There is such a lot of aerosols which are there. Nitrous oxide. Today we are talking about the greenhouse gases. We talk about the carbon dioxide. More than that, 20% time more is nitrous oxide, which is there in the air, in the aerosols. So this is all the wrong way we are going ahead. And if we have to treat, we have to together treat water, soil, and air. Then only we can say that the process what we are dealing with is the right method of going ahead with. So that's what.
Interrelated, and we need to work on all at the same time.
All are interconnected, we must say. Yeah.
So in this context, again, my question will be diverted towards bioenzymes.
Right.
So what is the potential effectiveness of biological methods in treating such industrial effluents in sewage water?
Yes. Now today, if we look at our system of carrying the drainage system or drainage network system, okay, most of the places wherever I have gone, I have observed that today we cannot say that any a particular network which comes from the domestic residential areas also, they only carry drainage. It's not true. Today, it's all the mixed kind of the effluents which are coming. Now, because of that, if we say that we can treat it with a particular manner, that we can take it to the STPs and we can treat it, I don't think it is possible. And that's what we proved with our principle and science of sewage. Our research has proved that. Because see, earlier there was no such, sophisticated microscopes and all which could tell us that what is happening. But today we have those kind of microscopes by which we are able to, at the molecular level or the genomic level, with the DNA sequencing and all, we are able to, at the genomic level, we come to know that what are the things which is present in the water, because we have to check our water quality in that manner. But today what is happening, we are not doing that way, but only with the one kind of a method which we have, we are trying to treat it. But in the process, as I said that it's a mixed one. I always found, like since the time we started with this bioenzymes, of course, actually, if I talk about bioenzyme is not something new. It started from 1951. It started with 1951 with Larry Ellert. who started it with the agriculture and for the animals, in animal feeds. And from there, it started in 1968. He also got a patent with the help of the fungi, which he could, add in the feed, and he was getting a very good results. And that's how bioenzymes was already there. And this is also in the US only it started. But, somewhere I feel, that always wrong things have been more propagated, shown the ways to us, but the right things which never could, take up in that much of scaling up. And that's how bioenzymes have taken a backseat. But today, with lot of our discussions, and thanks to our this wiki group and bioenzyme academy, that a lot of discussions, lot of awareness creating, lot of deliberations are happening in different ways. And because of that people have started understanding the importance of bioenzyme. Now, bioenzyme has got such a lot of potentials, let me tell you. Being having my background of science and from zoology, first my PhD was in zoology, toxicology, second one is in management, third I'm doing in social sciences and humanities, of course. But then having that, also microbiology was my subject in my undergraduation. So from all those point of view, when I did a lot of R&D into it, I understand that bioenzymes is the only product by which we can give treatment uniformly to not only to the chemicals but also to the organic matters together. Like they have the so much of capacity because of the plasticity and flexibility of the active site of the enzymes. We have, if I go at the molecular level, it will, our talk will go little bit, very, very long time. But to shorten it, I will tell you the bioenzyme molecular structure is such that if we look at it, it has got its potential to give the remediation for chemicals, give the remediations for the organic matters, and number of things, you can get it. Only thing is we have to know the right combinations for it. And because of that, today what is happening, whenever any kind of any kind of treatment or administration of bioenzyme is happening anywhere, we are talking very vaguely. We are saying that it is 80%, 60% achieve the results, or in terms of whatever the outcome we are seeing, like in the agricultural field, when we see so much of harvesting has been done. So depending upon the amount of things which is increasing or the growth which is there, on that terms we are saying that the bioenzyme has acted very well. But today it's time that we talk in terms of genomic level, metabolic pathways by which we can decipher it very well, that yes, these bioenzymes have lot of potentials to take care of chemicals as well as other things. So that's what I believe, that the potentials of bioenzymes are. And that is why we are giving a solution, for when we talk about bioenzymes, we are also trying to say that for the sewage treatment plants also, instead of sewage treatment plants, if we can make it into a constructed wetlands, because our bioenzymes in combination with this kind of a wetland structure, it will give a very, very positive result. Because as I initially only said, that any microbes to function, it is very, very important that they should have the soil and water kind of a situation where both are there, and the microbes of water and this soil, these when they come in symphony, they work very well. The bioenzymes work very well. Yes.
That's really great to hear, Snehal ji, that bioenzymes are the next big thing in the wastewater treatment.
Right.
So that was exactly my next question to you, for which you have already answered. So we'll go to the next question. How specifically do bioenzymes offer benefits for water bodies and the surrounding ecosystems? That also partially you have covered, but if you could throw some more.
Yes, yes. So to tell you very frankly that today, like it's a kind of a one point solution, we can say, that bioenzyme can treat soil, bioenzyme can treat air, bioenzyme can treat water. Only thing is, as I said, we have to decipher the molecular level of bioenzymes activity, how it acts, and in what manner, in what combination, if we do the things, how much like level of result we can achieve. So for that, it is important that we more and more we do, along with, administration of this bioenzyme, we do research along with it, because while we will be doing the research, lot of things get evolved, in the process, and lot of refinement comes into the place. So that is how I believe that this has got a lot of scope, and it's a big horizon where everybody has a lot of scope to work in this, and very well we can get all the solutions for air, water, and soil all together. Because as we know now, mostly when it comes to agriculture, we say that citrus is very good. Citrus, when we make the solution out of the citrus, we say it's very good. When we say about maybe that the drainage to be clean, then we say that, okay, little add of the papaya will be doing much more better. So this way, if we do little bit of experimentation with papain, what it is adding to, when it is, or maybe citrus and papain in combination, whether it will work, or sometimes we say that vegetable and fruit combination will work. So these all kinds of permutation combinations we have to explore, so that we can give a right kind of product with the combination, with the percentage, all these things very specifically, so that instead that we say that we have achieved 60% of the result, we will be very confident to say that 100% is also achievable. And at the same time, to convince, like today I'm able to convince to the authorities also, like corporations. Many of the corporations are working with me. We are working with the bioenzymes on the dumping grounds. We are working it on the lakes. We are working it on the nalas. We are working in the rivers also. Like, even I will tell you, to some extent, there is slaughterhouses which are there. Too many slaughterhouses. There also, like, we are trying to say that in a phase-wise manner, like, if, right now we are working in combination, because still we don't have any kind of studies which has been conducted in these fields, so that we can very, today I'm very careful while I'm making some statements, because we have not yet done to that level of research. Yet we are in a process, and once we are done with, we may probably be able to tell you that yes, for so many days, or maybe in so much of quantity, or maybe in so much of dilutions, that if you use this solution, that it will work. So a lot of research needs to be done in this yet.
I was just about to ask you about the slaughterhouse treatment, wastewater treatment, effluent treatment plant, because I recently saw your live on Facebook where you were there at the site and speaking to the people who were working over there.
Right.
So according to me, this bioenzymes would be more effective even on the organic effluent producing industry. And furthermore, more and more research is definitely required, as you said, and I'm sure under the shelter of Bioenzymes Entrepreneur Academy, there are quite a few researches which are going on as of now, and definitely to show something, we need it on the paper. So that would be really helpful if more and more researchers come further and try to work on this. So
a lot of even products which you like Preeti Rao, she's also making, and many others are making lot of products like cleaner. Then we are doing with the antibacterial, some soaps and many other things, to name. So with these kind of combination, like when I was in America, people were, after coming back, people were asking me, how are they treating their, these kind of, suppose the flush, like when they flush in their toilets, whether it is directly this complete organic matter goes directly to the STP, or how do they? But then in a lot many ways, they have progressed. Like they have come up with certain, products which they put it in their flush. While they flush their poop, that solution is mixed while it is flushing, and then automatically little degradation happen at that level. So such kind of products, if we come up, and even in the soaps and all, yet we are not giving so much seriousness to understand that how important is bioenzymes products if we buy, like soaps and other things, so that much of the acidity, alkalinity, on all these things we will reduce. The chemicals we have to reduce. Today, if you look at the STPs, whichever is fit at any place, they are only producing foams. Like if you talk about Yamuna, you talk about in Nasik, Godavari, many places wherever I have gone to see the STPs. It's only because the kind of product which are there in market today, they have lot of chemicals, lot of chemicals. And when they are fitting this STPs, see, we know the nature of bacteria or the enzymes are they are very specific to the very specific substrate that it will be working on. So if you just give one kind of a culture on the MBR, SBR and all, they are not able to degrade. But whereas the bioenzymes have shown the results that if you use any kind of a bioenzyme, it is working in a multi-dimensional way. So that is how we have to propagate these things, and more in our practices, in our daily life, that we have to use these products, and more promotion of such products have to be done. Still, I don't see in the TV channels and all, we have to yet that kind of recognition to these kind of products and items and articles are not being given. The promotion has to be more and more about this. In America, one more thing what I saw while I was conducting this study, that they have already restricted use of nitrates and phosphates in their these kind of toilet products and other products. So cutting down on these chemicals will be also one of the way. As we say that if we have to treat our lakes, before treating our lakes with bioenzymes, most important will be first we will have to divert our this drainage discharge and then treat it separately instead of discharging it in the lake and keep on treating the lakes. So it is that way. Precaution has to be taken before we go for the treatments. Yeah.
And here again, I would like to add to our viewers that it's not only the industries to be blamed, which I always keep telling. We as from our households, whatever the grey water, whatever the sewage water which goes and enters into the lakes, into the rivers, is also responsible, especially the surfactants, the cleaners which we use for our clothes, for our dishwashing, our everyday use are more harmful than the other industrial effluent as well. So
not only that, Yogita,
yes,
it is also see in the agriculture. Today
yeah.
in the agriculture, like they say about Jivamrit, okay? And this Jivamrit is nothing but bioenzymes. Again, again with the permutation combinations, like somebody is using either cow urine or cow dung and all these things to the bioenzymes, and then they are spraying it. How well it is able to enrich the soil microbial biodiversity. And because of that, the soil quality, the fertility which was lost because of the chemicals which are there in the pesticides and weedicides and all that. So instead of that, when these bioenzymes are being used in that, and more if it will be propagated, I think our soil quality will also become better day by day, and then fertility will be also good. Today it's becoming totally infertile, and then we are losing all the nutrient values.
Absolutely, ma'am. It's the next big thing in the entire industry, be it sewage treatment plant, be it wastewater treatment plant, be it agriculture, be it home cleaner. Bioenzyme is the solution for everything, I would say.
Right.
So again, something related to the same question, ma'am. What guidance, which you've already provided, but little more, if you could say about what guidance would you offer to individuals or businesses seeking to integrate bioenzymes into their wastewater treatment processes?
See, as I already mentioned, that guidance will be always that every day is a learning. And if we keep ourselves in that learning mode, and if we keep doing research with the different kind of combinations, because today bioenzymes have all the solutions to all the issues of the climate change. Because what is climate change ultimately? It's all about, because we have made our water bodies so bad and we are treating it so badly. Same way with the soil, same way with the air. So today, if you look at the even dust quality of our air, it's so bad. Other countries, it goes with the 20, we go with 200. Still we survive. And that's how we just, we are very careless about it. So but that's why I say that as much as we do innovations, as much we will be doing understanding the bioenzymes and we will be conducting research, I think that would help us a lot in in understanding our validation of our bioenzymes will also increase. So as much as we keep on doing the permutation combinations for the different kind of, solutions, and along with that, simultaneously, if we keep doing research, I think we will be very well getting through the solutions for everything. As I said, the same bioenzyme can be used for biomining. Same bioenzyme can be used for the STPs. Improvisement. Today, even I am talking to the this municipal corporations commissioners that how improvisement. See, they also say that, oh, such a big unit and so much of money we have poured in. What should we do now? Tell us what can be done. In, Karnataka and many other places, they have tried to little modify these structures with making some, soil beds also in one of the tank. So these possibilities are there. We have to only try to figure it out, that how we can do. If I am saying that the soil and water has to be there, soil bacteria can help this sewage water to, degrade. So how we can, pass it through this soil. So that way also we can do. Because today, if as we are suggesting the constructed wetlands, but the wetlands require a lot of big lands. Okay. And similarly, this STP is still little less, but then money is too much. It is recurring. Recurring cost is also too high. So today, what I am trying to suggest to any corporation is when they have the city parks, big city parks which have been announced. Now, this constructed wetlands or the soil biotechnology by means of this, bioenzymes use, these things can always provide a solution of a combination. Like these city parks can be in the form of this constructed wetlands. It can be a biodiversity park kind of. So bioenzymes use, and at the same time with a good greenery which can be made, and with the help of, because as I said, soil and water combination as well as the bioenzymes together, it is giving a very, very good result. So with this, if we can in combination such designing, architectures also can be taken into consideration while designing these things. I think very well in the combination, we can have good greenery, we can have good soil, we can have good symphony of the bacteria, and that's how we can treat our sewage as well as we can have solution to the waste management. Like I said about the dumping grounds, like garbage, so much of garbage is being produced today. Yesterday, I was reading a article where I'm seeing that the 80% of garbage has increased. Yes, it is increased. Now, instead of having suppose the steel pipettes, we have all the straw, these plastic pipettes and all. That because of that, what is happening, even for glass and plates and everything, if we stop all those things, I think we can reduce a lot of garbage. And today, if you go to any river body or any forest or any garden, everywhere literally you find garbage. So that is why for this garbage treatment also, I see that this bioremediation by help of bioenzymes is the best way, where you reduce this garbage first with the help of the bioenzyme. The reducing is also getting done very fast, as well as the odor which is coming. So, of course, the odor means what? We say always that odor is reduced means our bioenzyme is working well. It's not that is also not correct. When odor is there means there is some chemical reaction is happening and breakdown is happening. So in that process, that odor comes. But odor should not be for a very long time, or it should not be a very bad one. So it reduces, of course, and after some time, bioenzyme is able to completely neutralize. So this way, if we go ahead, I think bioenzyme is really a great blessing to all of us, that it's in fact, the making of a bioenzyme is so easy, so cheap, so cost effectively we can work. If we talk about in terms of others, like today, when biomining is happening at every site, you just find out it's a 4 lakhs tons of the garbage which is there, multiply it with suppose 18 rupees per kg, are it coming to 18 crores and all that, they are getting the funds. And whereas bioenzymes at a so cheaper level that not even, I don't think that if we take a very big place, 50 lakhs will be too much. But then we are able to solve the problem. But still, I don't know why the government or others are yet not paying attention to this formula of bioenzymes and to go ahead with this. I think, hope they understand, and now they have started understanding, and CPCB has also recommended, NGT has also recommended, but in few places, like just recently I saw one article in the newspaper in Pune, where they said that MPCB has said that bioenzymes are the chemicals which are being used. They have not taken the permission. That means that they have lost their mind, that they don't understand the science of it, and just they will talk anything to stop it, because there is no money which they can make out of the commissions. So because of that, we have to talk today more. We have to bring this in syllabus. We have to make it in a sense that from the school level to the higher education, that this course should be embedded in this manner, that we can guide to the students, teachers, stakeholders, everybody for these bioenzymes, and that's how we can, bring in a better world around us.
That's really amazing. By coming from you, highlighting bioenzymes so much is really a big thing for all the people who are hearing today, because bioenzymes, making of bioenzymes absolutely doesn't need any kind of an infrastructure. Raw material, again, if you see, what we need is the wet waste, fruit peels, which again would have been otherwise lying in the garbage, creating methane. So we are diverting the wet waste also. Plus, we need just a little bit of jaggery, which is not very expensive at all. And containers we can just use out of recycling. So making bioenzymes is like, again, waste, a proper kind of organic waste management for sure. But at the same time, if you're using the recyclable containers, again, the dry waste is also getting, reused. So likewise, everywhere, it's a win-win situation, I would say.
And not only that, today when we talk about the garbage management or the waste management, see, segregation is not happening. And then we are now trying to propose that segregation, collection and disposal at source. See, every house also can make this bioenzyme, and every house this can go on. That is the beauty of bioenzyme.
Absolutely.
So if everybody understands, so from every house, if we start this kind of a process of making bioenzymes and using it as much as in our toilets, in our cleaning and everything, like, then see, things will totally change. So it has to be individual level also, we have to go ahead, rather than in any kind of, in a system. It's starting from home, that if it is done, that means segregation, what we are talking today, a decentralized way of going ahead with the waste management. At the same time, when we say that the waste disposal at source, so this is the best method, that bioenzyme, it is 3:1:10 ratio that we make it. So it's a so simple making also. Nothing like, it's not a rocket science, or it will not require a lot of technology. You have to just take some container in which you are adding this fruit peels, 3 grams, 1 gram of jaggery, then 10 ml, 100 ml of water. Like that way, we are able to just keep it in a bottle, keep it tightly closed. After maybe for 15 days, keep it loose little, and then again tighten it just for 15 days, then forget it. That means with the fermentation process, and automatically there is a slurry which will be coming down, and clean solution will come up, and that solution we can very well use it everywhere. Nearby also, in our gardens, we can spray with that. So in every individual residential complexes also, they can use it. So I still feel why, and why there is still no much understanding among people regarding this. And as many, like, good that you have started this podcast now, and maybe with this, more and more people will know about it, and then they will try to understand what is it. And today, because of this Google Baba, every information is available. They don't have to search for solution, how to make it, how to apply it, how to use it. Everything is available.
Very true, very true. And that's what, rather than waiting for the governments to imply certain rules and regulations, why not take the responsibility upon oneself, be a responsible citizen, start segregating waste at source, start making your bioenzymes, start composting, start reusing, and then think about recycling, which should always be a last option. So I'm really glad to have you today, and we have discussed such wonderful things about bioenzymes, miracles about bioenzymes. And we in this academy say that bioenzyme is good for soil. So what is soil? Soil, air, and water. So we have seen, and it has come right from the experts. So now at least I think more and more people will start believing in us, believing in bioenzymes, that yes, bioenzyme is the next big thing coming towards for the which would fight the climate crisis, which would bring a more greener planet to us and to our generations to come. Any last address which you would like to give, Dr. Snehal, to our viewers today?
Yes, because this podcast is being made for the International Women Day also. And I see that in the bioenzymes today, most of the women are in forefront, and that's how I believe that the women should be more and more supported for the right cause. And whatever today is discussed, if the 1% of it also, if somebody takes it up and it propagates, I think a lot of people will get aware about these particular bioenzymes and the use of it. I think this will be then bringing a big revolution, and we will be very soon, we will be able to tackle with all the issues of water bodies, soil contamination, as well as the air pollution. So thank you very much for giving me this opportunity today to speak to the people, those who will be listening to me. And you were very nice host to me today. And yes, Preeti Rao and others, to give me an opportunity to be the first woman on this podcast to speak about bioenzymes. Thank you so much.
Thank you so much, Snehal ji, for taking out time from your busy schedule today for us. Thank you so much. And here's once again, wishing everyone a very happy Women's Day. Start making bioenzymes to make it even more happier. Thank you so much. Thank you.